Sanjay Bhardwaj from Department of Computer Science and Applications, DAV College for Girls, Yamunanagar. In this lecture, we will discuss logical gates, exclusive OR and exclusive NOR. In the previous two lectures, we discussed logical gates. In the first one, basic building blocks, that is AND gate, OR gate and NOT gate. In the next lecture, we discussed universal gates, that is NAND gate and NOR gates. In this lecture, we will be discussing other gates, that is exclusive OR and exclusive NOR. So, first of all, let it be what basically a gate is. As we discussed, gate is a logical circuit with one output and two or more inputs. The output is high for certain combinations of input, and these combination varies from gate to gate. As we saw in the OR gate, the output is high when all inputs are, when any of the input is high, and in AND gate the output is high when all inputs are high. Similarly, in each and every gate this combination varies. So, output is high for certain combination of input, and that combination is different for different gates. Now, in this lecture we will discuss exclusive OR gate. It is exclusive OR gate. In short, this gate is also known as XOR gate. XOR gate. As we were discussing, the first one is, that is definition. Definition. Now, XOR gate, it is a logical circuit with one output and two or more inputs. The output is high when number of high inputs are odd. This is very important. The output is high when the number of high inputs are odd. This is the logic of this gate, that is exclusive OR gate. Now, the next one is circuit diagram. Now, circuit diagram of this XOR gate is basically implementation of the equation A bar B and A B bar. For two inputs, this is implementation of this particular Boolean expression A bar B and A B bar. Now, in this expression we have two NOT gates and two AND gates, and another one is, that is OR gate, which is for addition. For complement I will be using NOT gates, for multiplication I will be using AND gate, and no doubt for addition the gate will be OR gate. Now, to implement this, or to implement the circuit diagram of the XOR gate, let the one input is A, NOT gate, this is the complement, this input is A, this output will be A bar. The another input is B, this is B, and with AND gate these two will be multiplied, and the output of this AND gate will be A bar B. Now, A, this is the input, here I got A bar, and the product of these two is A bar B. Another one, this is A and the second input is B bar, A B bar, and with AND gate this will be A B bar, and the sum of two, that is with the help of OR gate, and this will be Y, that is A bar B plus A B bar. Now, this is circuit diagram of exclusive OR gate or XOR gate. Now, next one is the working. As there are two inputs, we will have four combinations for this, that is A0 B0, A0 B1, A1 B0, and both values will be 1 1. We will start with the first one. Let it be A is equal to 0 and B is equal to 0. A is equal to 0 and B is equal to 0. We understand the working of basic building blocks, so we like to see what will be output y in this case. Now A is equal to 0, that means value of this A bar will be 1, because A is 0, the complement A bar will be 1. The second value B is 0, this value is 1 and this is 0. We know in AND gate the output will be high when all inputs are high, but here one of the input is 0. So 1 and 0, this A bar B is going to be 0. A is equal to 0, that means A bar is 1. B is equal to 0, now this 1 and this 0, the output is going to be 0. Now what about this? Since A is 0, no doubt B is 0 and B bar will be 1. This 0 and 1, the output again here will be 0. It is 0 because the B is 0. This is 0 because A is 0. And when these two are 0, the output of OR gate will be 0. That means y will be equal to 0. When both A and B are 0, y is going to be 0. Why? Because B is equal to 0 will give this value A bar B is equal to 0, and A is equal to 0 will give this value is equal to 0, and when both these values are 0, y is going to be 0 only. The next case, let it be A is equal to 0 and B is equal to 1. That is, A is equal to 0 and value of B is equal to 1. Now, since A is equal to 0, I hope the value of A bar is going to be 1. On the other hand, B is 1. So both of these values are 1. Since both the inputs of AND gate is equal to 1, this result will be equal to 1. A bar B, this value is going to be 1. What about the second gate? A is 0. Now this B bar will be again 0. When these both will be 0, the result of this AND gate will be 0. This value is 1, this value is 0. OR gate, with OR gate the output is going to be 1. That means y is equal to 1. Again I am repeating it. A is equal to 0, that means A bar is 1. B is equal to 1, both the inputs are 1. If both the inputs are 1, the output is going to be 1, this value will be equal to 1. Here A is equal to 0 and from B, B bar will be equal to 0. When both will be 0, this result will be 0. One input is 1, another one is 0, the output is going to be 1. That means y is equal to 1. Another one, A is equal to 1 and B is equal to 0. Now A is equal to 1, A bar is going to be 0, B is again 0. Since both are 0, the output of this AND gate will be 0. What about the second gate? A is 1, B is 0, but the B bar will be equal to 1. When both of these will be equal to 1, this A B bar will be equal to 1. This value is 0, this value is 1, y is going to be 1. Again A is equal to 1, that means A bar is equal to 0. B is also 0, both of these will be 0, that means this value is going to be 0. A is 1, B is 0, so B bar will be 1, both these values will be 1, that means this result will be 1. Now this is 0 and this one is 1, I hope y is going to be 1. Now the last case, and that case is A is equal to 1 and B is equal to 1. Both values are 1. Now A is equal to 1, that means A bar is going to be 0. B is equal to 1. Now this value is 0, this value is 1, the product is going to be 0. Now here A is equal to 1, B is equal to 1, B bar is 0. When this value is 1 and this value is 0, the output is going to be 0. This one is 0, this one is 0, positively their sum y is going to be 0. I hope from the working the definition of the gate is very clear. The output is high when number of high inputs are odd. In this case only one input is high, that is odd number. In this case one input is high, that is odd number. In this case two inputs are high, that is a even number, that is why y is 0. Here no input is high, again the value of y is equal to 0. I will be repeating the working again. The 4 cases I will be discussing again, like A is equal to 0 and B is equal to 0. Now A is equal to 0 means A bar is equal to 1, B is equal to 0. This is 1 and this is 0, this value is going to be 0. Now A is equal to 0, but B is equal to 0 will give B bar 1, this is 0, this is 1, this value is again going to be 0. And when both the values are 0, y will be equal to 0. This case is there, that is when A is equal to 0, B is equal to 0, y is going to be 0. The next one, A is equal to 0 and B is equal to 1. Now value of A is 0, positively A bar will be 1. B is already 1. When both are 1, I think A bar into B will be equal to 1. Now A is 0, B is 1, so B bar will be 0. Both 0, the result is going to be 0. Now if this value is 1, this value is 0, y will be equal to 1, and this is the case, that is y is equal to 1. The third one, A is equal to 1 and B is equal to 0. Now since A is equal to 1, A bar will be equal to 0, B is 0, now both will be 0. If both will be 0, this result is going to be 0. A is equal to 1, now B is 0, so complement will be 1. If both are 1, this value is going to be 1. Now this is 0, this is 1, and this value is going to be 1, that is y is equal to 1. Now the last case, that is A is equal to 1 and B is equal to 1. When A is equal to 1, A bar will be equal to 0. Now B is 1, 1, 0 and 1, this result is going to be 0, because if any of the input is 0, the output is going to be 0. Here A is equal to 1, B is equal to 1, B bar will be 0, so 1 and 0, this value is going to be 0, and when both of these values are 0, the result y is going to be 0. A logical circuit with one output, two or more inputs, the output is high when number of high inputs are odd. Truth table. Again and again we gave the definition of truth table, that is the table showing all input output combinations A, B and Y. When both are 0, the value of y is 0. When A is 0 and B is 1, number of high inputs odd, this result is going to be 1. When this is 1, this is 0, the result is going to be 1, and when both are 1, again the result is going to be 0. So definition is justified. The output is high when number of high inputs are odd. Symbol, if I say symbol, this is OR gate, and for exclusive OR gate this first line should be doubled. This gate is now exclusive OR gate or XOR gate. So, XOR gate is a logical circuit with one output and two or more inputs. The output is high when number of high inputs are odd. The next in the sequence is XNOR gate. This is XNOR gate. Now, name is suggesting XOR gate and NOT gate combination. This is XNOR gate, exclusive NOR gate. This is exclusive NOR gate or XNOR gate, exclusive NOR gate. We will start with the definition. It is a logical circuit with one output and two or more inputs. The output is high when number of high inputs are even. In XOR gate, the output was high when the number of high inputs are odd. In this case, the output is high when number of high inputs are even. This is XOR gate followed by NOT gate. Now, after definition it is circuit. So, circuit is simple. This gate, I hope this is XOR gate, exclusive OR gate. Now, this followed by NOT gate. This is nothing but XNOR gate. A, B, this value is Y dash and this value is the final output Y. Again 4 cases, A is equal to 0, B is equal to 0. Now, since A and B both are 0, the number of high inputs are 0. So, the output of XOR gate will be 0. So, Y dash is equal to 0 and after complement the value of Y will be equal to 1. So, when both are 0, the value of Y will be equal to 1. Second case, A is equal to 0, B is equal to 1. When A is equal to 0, B is equal to 1, the output of this exclusive OR gate will be 1. So, Y dash is equal to 1 and after complement the value of Y will be equal to 0. Y is equal to 0. Next case, and that is A is equal to 1, B is equal to 0. This is 1 and this is 0. Now, if A is equal to 1 and B is equal to 0, the output of exclusive OR gate will be 1 and positively the value of Y will be equal to 0. The last case, that is A is equal to 1 and B is equal to 1. A and B both equal to 1. So, when A and B are 1, I hope the value of this Y dash is going to be 0 and when this Y dash is equal to 0, Y is going to be 1. Y will be equal to 1. This is very clear from the working, the definition. It is a circuit with one output, two or more inputs. The output will be high when the number of high inputs are even, when the number of high inputs are even. Again, we will repeat the working of this particular gate. A is equal to 0, B is equal to 0. The output of this exclusive OR gate Y dash will be equal to 0. So, after complement the Y will be equal to 1. If this is 0, this is 1. So, if one of the input is 1, this exclusive OR gate Y dash, this will be equal to 1 and positively y will be equal to 0. Now again this is 1 and this is 0, the output of exclusive OR gate, this will be equal to 1 and y will be equal to 0. And the last possibility, when a is 1 and b is 1, XOR gate, this will be equal to 0 and y is going to be 1. So a logical circuit with one output and two or more inputs, the output will be high when number of high inputs are even. Truth table, that is a table showing all input output combinations A, B and this one is Y. When both are 0, yes, the output is going to be 1. If this is 0, this is 1, the output is going to be 0. This value is 1, B is 0, the value is going to be 0, and when both are 1, the output is going to be 1. The output is high when number of high inputs are even. Now say symbol, this is symbol of XNOR gate. First is XOR gate and followed by this is nothing but XNOR gate, XOR gate followed by this one, and that is not, this is XNOR gate. Now these two are the gates, one is XOR and another is XNOR gate. A very interesting fact what we learnt after going through all the gates. Now this XOR gate, this represents addition in which the carry is omitted after addition. Now here the important point is XOR gate, A plus B, this result will be mod 2 addition. This is indicated as addition of XOR gate. This means add A and B and neglect the carry if any. I say this means add A and B and neglect the carry if any. Like 0 plus 0, it will be 0, 0 plus 1, it will be 1, 1 plus 0, it will be 1. Now the case is 1 plus 1, 1 plus 1 is 0 and the carry is 1, and here the sum will going to be this 0. Now another interesting thing is we learnt 1 plus 1, 1 plus 1 is equal to 2. Now this was the most basic mathematics what we learnt, and that is the decimal number system, decimal number system. Then we learnt 1 plus 1 is equal to 1 0. This basically is binary number system. Yes, this is binary addition. Now in the previous lecture what we learnt is 1 plus 1 is equal to 1. This is nothing but OR addition. OR addition is like this, 1 plus 1 is equal to 1. And the last now what we learnt is 1 plus 1, this is equal to 0, and we call it mod 2 addition. And mod 2 addition is add the numbers and neglect the carry if any. Now by this time we must be very clear regarding this. If 1 plus 1 is equal to 2, we are in decimal number system. If 1 plus 1 is equal to 1 0, this is the binary number system. If I say 1 plus 1 is equal to 1, this is Boolean addition or the OR addition or gate addition. And if I say 1 plus 1 is equal to 0, this is nothing but exclusive OR addition, and this is indicated by this plus and then the circle over it, and this is known as mod 2 addition. This is nothing but XOR addition. Now there is a symbol which is also used for XNOR gate. Now XNOR gate, this operation is represented by dot and then the circle over the dot, like XOR gate is plus and the circle over it, and XNOR gate is dot and the circle over it. Now these are the two gates, that is XOR and XNOR gate. Now after going through these two gates, or going through this lecture, we must be able to answer some of the questions. One of the very simple question can be, what is XOR gate? Explain the working of XOR gate. Another can be XNOR gate and explain the working of XNOR gate. The question can be even, explain the working of XOR and XNOR gate. Another question can be, what do you mean by mod 2 addition? What is the symbolic representation of mod 2 addition and how it is implemented in digital circuit? How it is implemented in digital circuit? Now these two gates, this XOR and XNOR gate, these two gates can be even used for comparison, and we can have a question how we can compare two numbers by using XNOR gate. Now it is very simple. If you go through the truth table of XNOR gate, when both inputs are same, the output will be 1, and when both inputs are different, the output is going to be 0. I think this can be thought of as a way of comparing the two bits. Now I leave this question to you, just try to understand how this particular gate can be used for comparison. Thank you very much.